Alright, so this is actually going to be the second attempt I have made on this. The first attempt was an absolute disaster, and probably will never see the light of day on the channel. So what we have here is basically, I think they call it a Slayer exciter. It's sort of a mini Tesla coil kind of setup. Very similar to the way the Joule Thief works and the way that it uses feedback on a secondary winding to pulse a transistor on and off, with the difference of it's coupled with another inductor here with many thousands of turns. So it takes the little magnetic field here and converts it into a tremendous amount of voltage at low current on this side of the transformer. So it's very simple. We have a diode and we have a transistor with a very odd pinout. I'll demonstrate that later. A little resistor, a heatsink for the transistor, and some ancillary components. Now, if I was smart, I would have had my component tester close to hand so that I could show you the weird pinout of this transistor, but my component tester does not appear to be close at hand. That's interesting. Wonder what I did with it. Maybe it's in here. I still haven't quite figured out what I'm doing with these drawers. Apologies, headphone users. I'm probably making a tremendous amount of noise, but the microphone situation should improve in the next couple of weeks, because I'm hoping, very much hoping to order a new microphone. But it doesn't look like I have my component tester anywhere nearby, which frustrates me slightly. But anyway, in most transistors, the center pin is the base, but in this transistor, the first pin is the base. It goes base collector emitter. It's an unusual transistor, and it also has absolutely no identifying markings on it, so I don't even know a part number for this thing. The only other oddity in this one is this diode, which is marked as a UF4007, which actually is different from the diode that was in the original build, which I have here, which was just a standard 1N4007, which I think may have been a contributor to the failure of that kit, because you need a ultra-fast diode for this application, and that's what UF stands for. Otherwise, its electrical characteristics are the same as a 1N4007. They're just more expensive and have a much higher frequency response. That being said, I think we'll go ahead and start by soldering the diode into place. This should... Let's get into... Actually, you know what I'm going to do? I'm going to scooch this a little bit that way to make it easier for me to stay in shot. Alright, there we go. So, we'll just align the diode per the diagram on the PCB. That's also the advantage of this one. This one came with a PCB, so I don't have to figure out the wiring on a protoboard. Alright, so pretty simple. Just got the LED, or not the LED, the diode into place there. Looking good so far. Alright, let's toss the resistor in. This is the resistor that limits the amount of current to the base. So we'll go ahead and put that right in here where it's marked 120. It is a 120 ohm resistor, which for those following along at home, that'll be brown, yellow, brown for 1, 2, and then 1 additional 0, so 1, 2, 0. I'll solder that into place. It's a very simple circuit. I was very frustrated that the first attempt on it failed so abysmally, but oops, wow, I'm just bashing everything, aren't I? Alright, I think the next thing I'm going to want to try to do here is the transformer, T1. And how do I want to secure this? It comes with a little zap strap, and I think that's going to come up through the bottom here, and then I'm going to direct it through here, and out the other side, and then back down through the slot in the PCB, and then through here. I think that will be the ideal configuration. So let's just get that in there. There we go. Let's see. This is going to be a little challenging. Gotta keep tension on the zap strap while simultaneously not burning myself on the soldering iron and keeping everything in shot, and doing an absolutely dreadful job at all of it. Alright, here we go. That's I figure that's about as good as it's gonna get. Yeah, whatever. Let me maybe get it a little bit tighter. Yeah, looks like it. This is fiddly. Good enough. Alright. So, now with the transformer here, there are two thin wires, which are the feedback windings, and two thick wires, which are the primary windings. And what we have to do is... I forgot to turn off my multimeter when I was taking some measurements earlier. Alright, so if memory serves, we need to take one of the small leads of the transformer and put it through the hole here that has a small line on it. So we'll just run that through there, pull it through. And then we need to take the primary winding and the secondary winding from the opposite side of the transformer, so I'm hoping it's this one, and run it through the central hole here, which is marked with a thick line and a thin line. So let's just run that through there, pull it through, there we go, and then run the thick line through the same hole, or thick wire, I guess is better description. Alright, make sure we've got a little bit coming out there. Then we'll take the last thick wire and run it through the third hole, which is just marked with a thick line. I think that was the manufacturer's way of saying thick wires through here, thin wires through here. Now it's important when you're coupling the primary and secondary together that you do it on opposite sides, because you need the negative feedback on that. I think that's the term for it, at least. And now comes the challenge of soldering the enameled wire. So what I'm just going to do here is, being as it's not a heat sensitive component, I'm just going to hold the solder in place for a good while and let the solder boil the enamel away on its own. It takes a little bit longer, but it's a little more convenient. Alright, and I'll do this, do the same thing, just hold the soldering iron there, let the enamel burn off. I think that should be good. And repeat that process one more time over here. And that should be good. Now we can test to make sure that we successfully made our way through the enamel with the solder there with a continuity tester. We'll put one end of the continuity tester on the center here. We get a beep, and we get a beep. Excellent. So we successfully soldered the enamel wire. So the next thing I'm going to do is clean those up. Because of the length that I had to keep the solder molten, all of the flux from inside the solder would have boiled away. So I'm just going to clean these joints up a little bit with a little extra flux. There we go. How are we doing for time? I got 9 minutes, all right. Yeah, I emailed Nikon and asked them if they were planning on doing a firmware update to maybe automatically restart recording when the timer runs out, and they explained to me that the timer is in place to prevent overheating the CCD, which I suppose makes a certain amount of sense. So I'll just have to get used to having to keep an eye on my time and restarting the recording when it stops. Right, so the next step, I think, is going to be placing the transistor. So we're going to go ahead and put just a little, whoops, I said a little, oh bugger, that's way too much. There we go. Let's clean up this a little bit here. Yuck. I'm going to need some paper towel. Anyway, so we're going to take a little bit of heatsink compound and smear it onto the back of this transistor, and then I'm going to grab a paper towel to clean my finger off. There we go. Okay, so then we need to take this screw here and put it through the hole on the transistor, and then run that into the threads on the heatsink, like so. Now I'm not going to tighten it all the way down because I want to be able to position the screw's not even tightening down. Oh well. So we're going to go ahead and take that transistor and heatsink combo and discover that the PCB was not drilled very well. Interesting. Alright, so you got to get the holes on the transistor through the holes on the board, which is proving to be rather challenging. Why is this being so difficult? There. Not sanguine about how that isn't actually tightening. It's very concerning. I wonder if I have... I do. Where are they? Pardon me as I talk to myself a little bit while troubleshooting. Pardon the loud crunchy noises in the background here. I have different heat sinks here that may actually be threaded properly, because this one is not. It's just kind of spinning freely, so that's no good at all. The other advantage with this one being that it doesn't have the posts on it, so I can pretty much place it however I want. Alright. Yep. These threads are also working, so let's get that back into place. Oh, why is it being difficult again? There we go. Alright, now we'll solder one pin. There we go. And then we'll make sure it's nice and flush and centered. There we go. Alright, and then we'll solder the remaining pins. There we go. And then trim the excess leads. There we go. Alright, and then we'll just tighten that screw down just a little bit more to ensure a nice interface with the heatsink. Okay, I think the next thing I'll do is put the switch into place. Now, the switch is not... I should have done the switch a little bit ago. Let's see if I can kind of kludge a support. There we go. Alright, so let's go ahead and solder the switch into place, which is proving to be a little bit challenging. It's got a big blade there. It's probably not really meant for PCB soldering. It's probably better suited for like spade terminations, but we're making it work. So now that we've got it centered, we'll apply solder to the other terminal. Yeah, looking good. I think I want to trim this with my heavy-duty snips. That did not leave it as nice as I would have liked. Yeah, I'll attack those with a file later. Alright, so the only other thing we have to do is provide power, and I also need to make the spark gap. So for the spark gap, we're going to take some of these pins here, and I need my needle nose pliers, which are right here. We're going to pull out this second pin, maybe. Yeah, there we go. Second pin comes out, and then we'll just that real quick, reset the timer on the camera, and oh, that's interesting. Maybe I will use that for power. Anyway, so we basically want to make a slight bend in the tip. Oh, let's see if I can focus down on that. Oh. Can you focus, please? There we go. See how I bent the one lead in just a little bit there? We're going to repeat that on this side too, just to make it so that we've got a little bit of a spark gap. We want the resistance between these 2 points to be less than the resistance between those 2 points, so that we don't get any unwanted sparks. Alright, so the next thing I'm going to have to do is, let's grab these real quick. We're going to apply a little bit of solder to the ends of these pins. Like that. and like that. And we're going to put a little bit of solder on these wires. Ooh, that's a lot of bit of solder, but that's alright. Alright, and then we'll just go ahead and solder the leads from the transformer onto these pins. I'm going to need to flux that and clean that up a little bit, but I'll do that in just a second. There we go. Alright, where'd my flux go? There it is. Just going to clean this one up a little bit. There we go. Alright, now we just need to provide power. Now I'm planning on doing that from this thing over here, which I've plugged in. You're supposed to drive this off of a lithium-ion battery, which I currently have charged to 3.85 volts. Using these neat Wago connectors. I love these things. I'll probably do a video on them just on their own. Actually, you know what I'll do? I'll link to Big Clive's video on Wago connectors right here. Alright, anyway, so let's figure out... I don't want to really make this a permanent fixture, but oops, that's the negative. We want this to be positive. But I'm going to go ahead and semi-permanently mount this, like so. Run it up through the big hole and then down through the small hole, so it acts kind of like a strain relief, which you guys can't see me doing because I'm out of shot again. I became very keenly aware of my predilection for going out of shot when I did a premiere video the other day. I very rarely watch my own videos. I didn't really see any point in it because, hey, I recorded the thing. Why would I bother watching it? But yeah, it's kind of illuminating doing the premiere and seeing little things that I can do to potentially improve the quality of my recording. Alright, so let's carefully cut that so we don't short it, because there's a lot of energy in these batteries. Alright, so if I've done this correctly, let's get rid of anything potentially conductive, because I don't want anything arcing over on the bottom here. If I've done this correctly, I should be able to hit this switch and get a nice little arc. Let's quickly, I'm just going to kill the lights here. There we go. And if I hit that button, or hit the switch, we get a nice sustained high voltage arc there. And this one is continuing to work. Unlike the other one, which worked for about 5 seconds and then stopped. But I can take this and ignite it using the arc. You can also use it to, see, I can actually demonstrate that. Oof. That's interesting. That's not working. Alright. Well, I can see that it's getting very hot because it's starting to melt my little spark gap here. So I definitely can't use it for an extended period of time, at least not with the plastic there. I may need to fashion a better spark gap at some point. Holy cow, that gets really warm. Okay. Alright, well that went a lot better than the first attempt, which is over here. Piece of junk. Very angry about that. Anyway, so thanks so much for joining me. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting. Right here is the kit builds playlist, I guess. And right here is a Patreon link that you can use to help me buy more kits to build on the channel. So thanks so much for joining me, and we will see you next time. Bye bye.